Hey friends, in this video I'm going to show you how to use linear approximation to estimate the value of 0.99 cubed. This is the formula that should come into your head whenever you see these buzzwords, linear approximation. Let's break down each element of this formula. First, what is our x and what is our f of x? Well, that is always given to us in the prompt. Look at the number that you're doing some function to. Here we have 0.99 raised to the third power. So that means 0.99 is our x, and since we're raising it to the third power, x cubed is our function. Looks like we're doing a derivative up here, so let's do that calculus. Take the derivative of f, and you get 3x squared. You may be wondering at this point, why are we doing f of x and f prime of x though? Because up here I'm seeing f of a and f prime of a. That's a fair point. A is a value that we have to pick. Use two parameters to determine what your A is going to be. First, your A is going to be a number that is close to your x, very close to your x. And second, your A is going to be easier to plug into this function than your x is. Here we're going to set our A equal to 1. We pick 1 as our A because 1 is very close to 0.99, and because for most folks it's much easier to plug 1 into x cubed than it is to multiply 0.99 times 0.99 times 0.99. That actually brings us to our f of a. Plug in a equals 1 here to get 1 cubed, or just 1. Same thing for our derivative. We have f prime of a, so plug in 1 for a in this formula. You get 3 times 1 squared, which is just 3. All right, at this point we have all the elements we need to plug into our linear approximation formula and solve. First up, we figured out our f of a is equal to 1 plus our f prime of a, which we've calculated to be 3, times x minus a. We know our x is 0.99 minus our a, which we know is 1. When we work that arithmetic out, that leads us to L of x, or our linear approximation of 0.99 to the cube, as 0.97. Now to double check this answer, we can actually just plug in 0.99 cubed in our calculator to get 0.970299. We can be confident that our L of x, 0.97, is accurate, or close, a close enough approximation I should say, because it is only maybe less than 3/10,000ths off of our calculator answer. Couple things to keep in mind when you're doing this problem. Do not go fast and loose on your derivatives because you're bound to make a mistake. Take it nice and easy on the derivatives. Make sure you're doing the right derivative, because you could set this whole thing up right, have the wrong derivative, and then you get the wrong answer. Similarly with this x minus a, it's x minus a. Subtraction is not commutative. You cannot do 1 minus 0.99 and expect to get the same thing. You got to respect the order. X comes first. Oftentimes, like in this problem, you're going to end up with a negative value here for your x minus a, which translates into your answer. So make sure you subtract in the right order. Okay, if you found this video helpful, if you want to see a few other linear approximation tutorials or examples, I've linked those here if you want to go ahead and check those out. Otherwise, I'll see you in the next video. Keep a good thought.